So guys, another scientist, Gay-Lussac, study relationship between pressure and temperature. So from 4 properties of gases, we already know relationship between pressure and volume. And then we just studied relationship between temperature. And volume. And now, Gay-Lussac studied relationship between pressure and temperature. Are these two related together? Pressure and temperature, do they relate together? So in this experiment, again, we are keeping 2 of these parameters constant, the other 2 are changing. So we have a gaseous system here that at a temperature of 200 Kelvin, it has a pressure of 1 atmosphere. We want to see what happens if we increase the temperature. In this case, we double the temperature. Experimental studies showed that pressure went up proportionally. You double temperature, pressure is double. So Gay-Lussac says, okay, let's calculate ratio of pressure over temperature, P1 over T1. What do I get? P1 is 1 atm over 200 K. And then calculate P2 over T2. Is it 2 atm over 400 K? Can I divide top and bottom by the same number and the ratio is staying the same? So 1 atm, if I divide 2 atm by 2, I get 1 atm. And if I divide 400 by 2, I get 200. Okay, do you see the ratio of pressure over temperature remains constant? That's the case where we are not changing the volume and amount of the gas is not changing. All right. So suppose you are designing a reaction tower, a reaction vessel. And when reactants react together, you're applying heat for reaction. A lot of heat. Do you need to calculate the final pressure to avoid explosion of the vessel? So Gay-Lussac equation lets you do that. You're starting with certain pressure, let's say 2 atmosphere, at certain temperature, 18 degrees of Celsius, which is 291 K. And you want to see what happens to pressure if you change the temperature to 335 Kelvin to see if this thickness of the wall of this container can take that high pressure. Another word, you have P1, T1, you have final temperature T2. Can you calculate P2? So did we say pressure over temperature remains constant when number of moles of the gas and volume of the container is fixed, volume of the gas? So can I write P1 over T1 is equal P2 over T2? What are we asking? Final pressure when you increase the temperature. So the question is P2. How would you solve this equation for P2? Can I do cross multiplication saying that T1 times P2 is equal to T2 times P1? How do you solve this equation for P2? Do you divide both sides by coefficient of unknown? Our unknown is P2. If I divide both sides by coefficient of unknown, which is T1, I can cancel T1 here. I'm left only with P2, and the other side, I have T2 times P1 over T1, which is the same as here. And I gave you the value of P1, which is 2 atmosphere. Final temperature, we said 335 Kelvin. Original temperature was 291 Kelvin. So you get the new pressure when you increase the temperature. So that's the application of Gay-Lussac's law. Do I make sense? Any question? Any question? All right. Go, guys. Let's do this. Three participants. Good job, guys. Great job, guys. Good job. So let's look at this. Did we say that pressure and volume are inversely related? So can we say when volume is decreased, pressure would be increased? Did we say that temperature and volume are proportionally related? You increase one, the other one is increased. So when we decrease volume, temperature must decrease as well. And in this case, if we change the volume, suppose we increase the volume, so pressure is going to decrease because they are inversely related. We are increasing the volume from 12 to 24, pressure must be decreased because pressure and volume are inversely related. Just think of the bicycle pump. You reduce the air by pumping, let's say from full pump to half a pump. You're decreasing the volume, pressure increases. What if we are increasing the temperature? Temperature and volume are directly related. The higher the temperature, the larger the volume.